This video is on coordinate geometry. We are going to be using the properties of quadrilaterals to answer questions and to prove mathematically what the quadrilateral is, and to use quadrilateral area formulas to be able to find the area and to be able to find the perimeter. We'll also be using slope and distance to be able to do all of this. So for quadrilaterals, the way a quadrilateral is named is very important. The letters that are beside each other represent vertices that share a side. For example, rectangle ABCD means that A connects to B, B connects to C, C connects to D, and then D connects back to A. Examples that we're going to do are find the missing vertex of a rectangle, parallelogram, or rhombus. If coordinates A, B, and C are three vertices of a parallelogram, ABCD, we need to find the coordinate of D. So thinking about parallelogram, a parallelogram states that opposite sides are parallel and opposite sides are congruent. So if we're looking at ABCD, so from A to B, then B to C would connect. So A to B would be maybe the top. Segment AB is going to be parallel, not to BC, but to the next one, which is CD. So we have to skip them. So then if we have segment BC, segment BC is parallel to AD, segment AD. So let's draw out our coordinates. So A is at -2, 1. This is coordinate A. B is at 4, 3, 1, 2, 3, 4, 1, 2, 3. C is at coordinate 6, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. This is C. So we need to find the coordinate of D. We need to find the slope to show that we have parallel. AB has to be parallel to CD, which I don't have coordinate D. BC has to be parallel to segment AD, so we don't have D yet. Let's find the slope of AB or BC. So the slope of, let's go with B to C. So BC slope is, so our change in y would go from 1, 2, 3, positive 3, and then our change in x would be 1, 2, change of 2. So that would be positive 3 over positive 2. So the slope of BC has to be the same as the slope from A to D. So from B to C will be the same as from A to D. So if I go from up 3 and then right 2, I'll do the same thing with A. 1, 2, 3, 1, 2. This might be the coordinate of D. So let's check that. A to B should be parallel from C to D. So our slope from A to B would be change in y of 2, change in x of 1, 2, 3, 4, 5, 6. So 2 and then 6. So if we go from D to C, 1, 2, 1, 2, 3, 4, 5, 6. Yes, they are the same slope. So if we were to connect these, we would have a parallelogram. So coordinate D is at the coordinate of 0, 1, 2, 3, 4. D is at coordinate 0, 4. And that is our answer. Using slope, we were able to find the coordinate. We did not have to use the distance because we know the properties of a parallelogram. Question 2 says that square WXYZ has vertices WX and Y. We need to find the coordinate of Z. So some of the properties of a square is that if we're dealing with slope and not distance, that we have sides that are parallel, opposite sides are parallel, but connecting sides are congruent. So if we were to draw a square, a base of square, and I said W x, so w to x, then x to y, then y to z. So now I can actually name them. So I know that using WX, segment WX would be parallel to segment ZY, but using Z to help us, because we don't know Z, that WZ needs to be perpendicular to ZY. Something like that. So we can use this information to help us. So now if we go and plot our coordinates, W is at -1, 3. Then X is at 0, -2. Y is at 5, -1. And we don't know where Z is. So we know that WX has to be parallel to ZY. So let's find the slope of WX. So WX slope will equal to change in Y of 1, 2, 3, 4, 5, -5 over a +1. So we have to use that same slope to get from Y to Z. So in order to do this, we have to do a change in Y, but we need to go backwards. So we need to go, this is the same thing as saying a +5 over a -1. Because if we go down 5, 1, 2, 3, 4, 5, and then a +1, this is not where Z will be located. That does not make a square. So if we go the opposite way, if we go up 5, 1, 2, 3, 4, 5, and then left 1 for the negative, this might make a square. So let's check that our slope for WZ is parallel to XY. So up 1, so a change in 1 over 1, 2, 3, 4, 5, right 5. So change in 1, 1, 2, 3, 4, 5, and a +5. So those are parallel. Let's make sure that the WZ is perpendicular to ZY now, and WZ is perpendicular to WX. So our WZ slope is now a +1, a +1 in the Y, and a +5 in the X. So these are reciprocals. 5 over 1 and is 1 over 5 as a reciprocal. One of these negative, one is positive. These are opposite reciprocals. Therefore, this is the coordinate of Z. So we now have a square if we were to connect these. And it does go W, then X, X to Y, Y to Z. It looks different than this one because this was just a basic sketch. So the coordinate of Z is at coordinate 1, 2, 3, 4, 1, 2, 3, 4. 4, 4. On our next question, it says to find the perimeter of parallelogram ABCD with the vertices of ABCD. It says round to the nearest tenth if necessary. So perimeter means we need to find the lengths of all of the sides. That means we need to find the distance of all the sides. So we're going to use the distance formula. And since it's a parallelogram, we know that the opposite sides are congruent. So we only need to find 2 distances. So we need to find coordinate A is at -3, 4. B is at 0, 6. C is at 4, -1. And D is at 1, -3. So this is our shape. We have graphed it. Now we know that in a parallelogram that the top and bottom will be the same distance and the left and right will be the same distance. So we need to find the distance of 2 sides, and then we know what the other 2 sides are. So A to B, side AB and side CD will be the same. So they will be equal. So it's equal to length of CD. So let's find that length. So from A to B, I'm going to do the Pythagorean theorem because it's distance. I went up a distance of 2, and then I went 1, 2, 3, distance of 3. So I did the distance is equal to the square root of 2 squared plus 3 squared, which is equal to the square root of 4 plus 9, which is equal to the square root of 13. So now on the next one, I will find the distance of from B to C. And I could have done A to D because BC has to be equal to the length of AD. So from B to C, I have 1, 2, 3, 4, a length of 4 here, and a length of 1, 2, 3, 4, 5, 6, 7 here. So I'll have the distance is equal to the square root of 4 squared plus 7 squared, which will equal to the square root of 16 plus 49. So I have equals to the square root of 65. So I have all the distances because I have that AB is the square root of 13 and so is CD. BC is the square root of 65 and so is AD. So to find the perimeter, I have 2 of square roots of 13. So I have square root of 13 plus the square root of 13 because those are the two sides for AB and CD. But I also have the square root of 65 plus the square root of 65 because I have all 4 of them. Make sure we get out of the square root when we add them in our calculator, and we get that the perimeter, because we're answering the question, is approximately 23 3/10 units. And that's our final answer. Because we answered the question of what is the perimeter, and we rounded it to the nearest tenth if necessary. This last question asks us to find the area of a rectangle. Now, if we remember, area of a rectangle is equal to base times height. Now, the height comes from a right angle, and a rectangle has a right angle. So that is helpful to us knowing that our base and our height, whatever they are just going to be the side lengths of our rectangle. So in this case, it's just going to be length times width. So we have our rectangle coordinates of h is 1, -3. I is at 2, 0. J is at -4, 2. And K is at -5, -1. So it's H to I, H to I to J, J to K, and then K goes back to H. So to find the area, we need our length times our width. So it's also area can equal to length times width. So since this is a rectangle, we have a right angle. So we have our height and we have our base. We just got to find the length. So we'll take either two sides. So we'll say our base, let's call our base be K to H. Because it could be KJ. So base is KH. Let's use our height, which is another side, will have to be a connecting side. So if I use my base as KH, I use my height as KJ. So let's go to KH. So KH, distance, is equal to the square root of, count that out. From K to H, we have a distance of 2, and then 1, 2, 3, 4, 5, 6, a distance of 6. So we have 2 squared plus 6 squared, which is equal to the square root of 4 plus 36, which is equal to the square root of 40. So we're going to leave it as the square root of 40 for now. Then we want to do the height of K to J. So we go from K to J. So we have 1, 2, 3, and then a distance of 1. So from K to J, we have the square root of 3 squared plus 1 squared. So we have the square root of 9 plus 1. So we have the square root of 10. So our base is the square root of 40, and our height is the square root of 10 units. So to find the area, we take the square root of 40, we get out of that, and we times it by the square root of 10. We get out of that, and we press enter. The area gives us, we do not have to round to the nearest tenth, it gives us 20, but then we have to use units squared because we did the base times the height. So we did a unit times a unit, which gives us unit squared. This is our area. And area is how many squares, full squares, can we count inside of here. So we could count 20 full squares inside of there. And this is quadrilaterals.